nice that they're not just saying, oh yeah, you need to go remember your stuff here. So I'll refer to that properties of logarithm sheet. So for the first one here, we're using this property on the right here, number 2. And sometimes it's easier to think of it as a top and a bottom. And you might even remember me saying it's top minus bottom at some point. So it becomes natural log of x minus natural log of 4. The instructions here say to expand. The other way is condense. So that's that one for that one. Okay, we should do a lot of these. They're pretty quick. I'd like to do 22 because it
Yeah, for sure.
kind
Okay.
of it has like another little thing in here that's, you know, kind of important to write. So when
Okay.
there's not a number written above the root, it's the square root.
Right.
And if you recall the square root of x, there's a 1 there and a 2 there. It's really 1/2 power. But more generally, let me see if actually this sheet has it. I always like using these reference sheets. It doesn't really. Oh, it does have it. They use n and m, and so this becomes x to the m over n power. So in your problem, this is the natural log of 5 over 2.
Yeah. Okay.
Like it's better to do that. Now, we're going to use the property of logarithms number 3, and you don't the numbering isn't important. It's just that you know all these. What this one says is that you bring the exponent out in front. See how the exponent's now in front?
Yeah.
So you're going to do the same thing. You're going to bring the exponent out in front. So it's 5 over 2 natural log x, like that. And that is it. So the idea with these beginning problems is that you're going to do like one property each time, and then eventually they build you up to problems where you have to use more than one property at a time. So we'll kind of see that in 23. All right, so this one again, I see it as a top over a bottom. So we're going to use that. We're going to use that first property up here where there's a top and a bottom. So the top or the bottom could be more than one thing. And keep in mind, x just refers to the top and y just refers to the bottom. So this xy is the top, the z is the bottom. So it's the natural log of xy minus the natural log of z.
Yep.
Sometimes books you see parentheses around them. I like them because it kind of holds the thing you're taking the logarithm of. Like there's no question about it from a formatting standpoint. But when you're using computers, you know, they can put the spaces in really well, whereas we don't hand draw them very well. But this is that. So it's kind of like factoring where you don't know if you're ever done, but this one on the left here is a product. So the idea with the second rule is that a quotient, division, becomes a difference. Well, a product becomes a sum. So if we look at the first property here in this reference sheet, the product, well, that's scaled really bad when I did that. Okay, the product becomes a sum. So this first one becomes the natural log of x plus the natural log of y minus the natural log of z. And that is your final answer. So this leads to kind of a generalization, which is that things on the top are positive, meaning there's a plus in front of them. See how the x is on top plus natural log of x, y is on top plus natural log of y. And things on the bottom are negative, but really that means subtraction. See how there's a negative in front of the natural log of z?
Yeah.
Okay, so like, let's just say I made something more complicated. Like I said, the natural log of a, b, c over d, e, f, g. If it's in the top, it's positive. So it's natural log of a plus the natural log of b plus the natural log of c minus the natural log of d minus the natural log of e minus the natural log of f minus the natural log of g. So if it's in the top, it's positive, plus if it's in the bottom, it's it's negative.
Right.
And that's an important generalization to make, which, I try not to do that unless it is really important because it'll save you so much time than trying to deal with negatives and stuff. So I think we should look at 25 next, if you're okay with that.
Yeah, that's fine.
Okay, so again, always good to kind of do that rewrite that I was talking about. Natural log of x squared plus 5 to the 1/2 power. And these are multiplying inside there. So do you see that this is a product?
Yes.
Okay, so that's the product becomes the sum. So this becomes natural log of x plus natural log x squared plus 5 to the 1/2 power. So when you look at those rules, you generally, when you expand them here, let me grab the 4 rules. There's not really an order of operations, but it's generally in this order when you expand. And when you condense, which I don't really like that word, but that's what they use, condense, you go the other direction generally, Pareto principle 80% of the time kind of thing. Okay, so we've expanded with product, the sum. This exponent comes next. So if there's a plus inside here, that doesn't matter. This exponent doesn't matter because it's the whole thing to the 1/2 power. So the next thing is to bring that 1/2 out in front, natural log of x plus 1/2 natural log x squared plus 5. And these, by the way, lend themselves really nicely to exam questions. Lots of places to go wrong on these that, and these aren't difficult relative to other stuff you will do, but something to think about.
Right.
So let's see. I mean, I don't know, 20, maybe 28 and 29 are more difficult, 27, 28, 29. There are a few like types that we're missing, but maybe they're not getting into that much depth here. Let me see where you're going with this. I guess you're going back to derivatives. Okay. Yeah, so let's go to the next grouping of questions, 31 through 36.
Yep.
So let's just we'll do a bunch of these here. 31. So 31. So it says to write it as a single logarithm. Okay. And I'm not sure why this is misunderstood. Like when you read the word single, I mean, if you're single, you know what that means. You're by yourself. So there's only one ln in your final answer.
Right.
Like there better not be two. And you'll be surprised how many times there's an answer like this, natural log of x over natural log of y. And this is completely wrong.
Right.
It can only have one ln. Okay. So those 4 properties I showed you now, we're going kind of, and it's kind of like we're going instead of looking at them left to right, we're now looking at them right to left. So this is a difference. So the difference becomes a quotient.
Right.
So what goes on top, what goes on bottom? Well, the positive one goes on top and the negative one goes on the bottom,
Yeah.
like that. Single logarithm, one ln. There cannot be two.
Yep.
Any questions, thoughts on that before we proceed to 32?
Nope.
All right. Okay. As I mentioned before, you apply them sort of in this bottom up, bottom to top. So there's this phrase in business, it's called top down. I don't know if there's a bottom up phrase, but that's kind of what we're going bottom up. So this exponent one here, number 3, is the first one to apply here. So if you see a number in front, it becomes the exponent. So it's natural log x cubed plus natural log of y squared minus natural log z to the 4th. Okay, now You could treat this as -4 power here, but I would not recommend doing that. I would recommend just keeping it as subtraction, using that rule. If it's positive, it stays on the top. If it's subtracted, it stays on the bottom. So what goes on the top here? Can you tell me
Yeah,
that?
natural log of x to the third times y to the second over z to the fourth.
All right. So here. Really want you to try some, but I'm not seeing great questions. Let me do 34, I guess. I'll have you try 33. So this one's got a 2 in front, but you can see there's brackets there. But generally in math, you alternate between parentheses and brackets. Though you rarely see problems that sophisticated where you need all that. But if you look at, maybe you'll read, I don't know if you're gonna go to graduate school, maybe you'll read a paper where it's got extra sets of brackets and stuff. Now you'll know why. But that two gets distributed into everything.
Right.
So it's 2 ln x minus 2 ln x plus 1 minus 2 ln x minus 1, like that. So I'd like you to take the problem from here and see if you can work it out, condense it to a single logarithm.
Natural log of x squared times x minus 1 squared over x plus 1 squared.
These are both negative here. They both go on the bottom. So it's going to be x plus 1 squared and x minus 1 squared.
Oh, they just go, oh, okay. I thought it was like you would divide like both of them because they're both negative. Okay, that makes more sense.
Right. Let's go back to the previous one. We'll look at that a little bit together. All right, so kind of like the last one, you've got this number on the outside, 1/3. So you're going to distribute that in everything. So it's 2/3 natural log x plus 3 plus 2/3, right, 1/3. 1/3 natural log of x minus 1/3 natural log x squared minus 1, like that. So again, why don't you try this from here? See if you can figure out what goes on the top.
The natural log of x plus 3 to the 2/3 power times x to the 1/3 power all over x squared minus 1 to the 1/3 power.
Good, good, very good. So now a couple of things here. This could be rewritten a few different ways, which is probably the only kind of thing I'm going to be able to. You basically got it down. So the first thing is that it can be written as the cube root of x plus 3 squared, like that,
Right.
times the cube root of okay, over the cube root of x squared minus 1.
Yeah.
That's option 1. Now, because these are both cube roots, you could actually put them under the same cube root. So it'd be cube root of x times x plus 3 squared. If you're wondering why did I put the x in front, it's just because it's more commonly put in front when it's a single term, over the cube root of x squared minus 1, like that. But furthermore, you could see it this way, where it's the cube root of everything,
Yeah.
x times x plus 3 squared over x squared minus 1, natural log of all that. Now you might think, well, why couldn't I do that from the beginning? The answer is you could have. So let me grab this question here one more time so you could see that. So what you could have done is weighted on this part. If you're like me, you don't have any patience, but you would get x plus 3 squared times x over x squared minus 1, like that, times 1/3. And then you could bring the 1/3 here. You follow that? How that would be?
Yeah.
And then now it's the natural log of the cube root of x times x plus 3 squared over x squared minus 1. This is a great exam question because the answer space, I mean, like any of these lines are correct, 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 correct. It's most likely going to be in this form, but I don't write your test. So. All right, so having thought all that here, why don't you try 35 on your own? It's not really, I think it's actually easier than the ones we just did, but um, you can take that. Just let me know if you have any questions on that.
The natural log of 16 over the square root of x to the 3rd plus 6x.
Very good. Yeah, perfect. Okay, so I feel like you have it. So we can move on to 43 through 49 grouping.
Okay.
So the idea here is that, now that you have this knowledge of logarithms, you can use that to answer this question. So we've done this problem a couple of ways now. I think, like I've mentioned to you that y equals the natural log of u, then the derivative is derivative is 1 over u times u prime. Okay. Have we studied that? And this is the chain rule and stuff.
Right.
Okay, so the derivative of this f prime of x is 1 over 3x times 3, which is 1 over x. Okay. So the idea though here is that why are we doing this? Sorry, I'm looking for the problems where this actually matters. I guess these don't matter. Okay. Sorry, I thought they were going to different directions. So you could use these properties of logarithms that we've been using where the product becomes a sum. This
Okay.
is just a rewrite step. That's where I thought we were going. It does not look like we're going in that direction. So no. All right. So the derivative of this is the derivative of natural log of 3. That's a constant. So the derivative of a constant is 0. Derivative of natural log of x is 1 over x. And you'd see how that's the same.
So you just split them up and then took the derivative of each one?
Well, that's where I thought we were going. So let me give you one example where it actually matters.
Okay.
And then we'll go back to doing these. Like, that's where I thought you were going. But that's not where you're going. You know what they say about assuming. Mostly me here on this side. So like this is where I thought they were going. Let's say that you were supposed to take the derivative of like x minus 1 squared times x plus 1 over x minus 2, like that. Okay. So if you were asked to take the derivative of this, it's 1 over the inside function times the derivative of this, which is quotient rule,
Right.
which is awful, right?
Yeah.
Okay. And this is where I thought they're in. But if you use the properties of logarithms and you expand this, and you get 2 natural log x minus 1 plus natural log x plus 1 minus natural log x minus 2. Well, the derivative is very easy now. There's no quotient rule. It's 2 over x minus 1 plus 1 over x plus 1 minus 1 over x minus 2. It's the derivative is 1 over u. The derivative of the inside function is 1 in all cases. That's the direction I thought they were going. That is not the direction they're going in your textbook here. So so we'll get back to doing 44, 45, but this is the kind of problem. Like I would ask your instructor, look in the notes, videos, and see if this is more the problem you're seeing, or if it's more like the ones that we're doing in the work here.
Let me see, because he assigned it doesn't look like he assigned like the more complicated ones like that. Like we have some that are more complicated, but the only one that he really assigned that was more complicated was 51. I think I sent that 51.
We don't have 51.
Oh, did I not send that?
No.
Yeah, or like 49, even 51 like is almost exactly like 49.
Yeah, 49, 48. They're some of the same. I mean,
Yeah,
these
they
should have
are.
come up. It should have come up a month ago. Truthfully, like, so whatever.
Yeah, or even like 62 through 66. Those are probably the most complicated ones.
those are those are kind of related.
Yeah.
Kind of. They're not like 65 is the only one that's really close to what I did. But let's do a
Yeah.
few more of these.
Okay.
So again, your derivative is 1 over the inside function times the derivative of the inside function. What's the derivative of the inside function?
X.
What's the derivative of x?
Derivative of X is just, oh, 1. It would be 1.
1. Yeah, so a lot of times you are multiplying by 1. All right, so let me have you try on your own here. So again, it's 1 over the inside function, 1 over the inside function times the derivative of the inside function. So why don't you try 45 here on your own? If you have questions, please ask.
Okay. Two X over X squared plus 3.
You got it. All right, so 47 is a little bit different. This one, it's nice the way they've written this. So this is not the same as, and I want to show this because I think that sometimes students can mistake these. This is not the same as this on the right. The one on the left here is actually natural log of x times natural log of x times natural log of x times natural log of x.
Right.
Okay, so the derivative here in our rewrite, it's really u to the fourth where u is natural log of x. It's really a chain rule problem where you're taking the derivative using power rule and then multiplying by the derivative of the inside function here. So what is the derivative of u to the fourth? Can you tell me that?
4U to the third.
Or u to the third times u prime. What is u prime? What's the derivative of natural log of x
1
over
over,
x?
yeah.
1 over the inside function times the derivative of the inside function. The inside function is x. So you'll see a lot of students multiplying by 1. And yeah, it's fine to do that. It's just not necessary. It's still the same. Now you put back in your u and so it's 4 parentheses natural log of x cubed times 1 over x.
And then it would just be like that. That's how you would submit it.
That's it. I mean, you could clean it up a little bit and put, 4 natural log of x cubed over x like that.
Right.
Okay, let's look at 48. 48 is a really common question to get in kind of these min-max problems. I'm kind of surprised it's showing up here, but that's what it is. So this is a product rule.
Yeah.
So f is x squared, g is natural log of x. Why don't you try this one on your own? If you need me to write a product rule, I can.
I was just
This would be
about
a
to
good one.
ask that. I remember it's
Yeah.
like F times G prime plus F
Yeah,
prime.
basically you're pairing one original with the derivative of the other,
Right.
then the flip of it.
How do we multiply the natural log of x and 2x?
You do not, they just stay
Oh.
together.
They just stay, okay. So then it would just be x plus the natural log of x times 2x.
So typically that 2x would come out in front and
Oh, yeah.
you got the right thing there where you did the cancellation. That's good. So the reason why this is like a common min-max question is because you could factor out an x, you can end up solving this for critical points. I believe the graph even looks, it's typically looks something like where it's got a thing like that. So it's diverge. Okay. Does Amazon ring your doorbell when they deliver?
No, typically no.
Yeah, yeah, I know. It's like they send you the email and. All right, so this one is a lot like 43. Actually, let me do this one real quick. So what you could do is bring that 2 out in front. And then the derivative is 2 times 1 over t plus 1. Derivative of p plus 1 is 1. Then ends up just being 2 over t plus 1. So we should do we'll do like 63. I don't know. We should do a lot of these. Like these are all kind of in the realm of being okay. This one looks more complicated than it actually is. There's no products or quotients inside here, so the derivative is 1 over the inside function like this. But then you have to be able to take the derivative of the inside function now. So I'd like you to try that. It's always 1 over the inside function times the derivative of the inside function. Like you to work this out here if you can, please.
So it would be 1 plus 4x, 4 plus x squared to the power of half.
Well, that's the rewrite part. Like if you want to rewrite that's good to do.
Oh,
You still have to take a derivative using power rule and then chain rule. Because there's the chain is the inside part, the inside function.
four plus x squared to the half power plus x over x squared plus x times 4 plus x squared to the power of half plus 4.
We're talking about I mean, the derivative of x is one, we're talking about this one, which is the power, right? 1/2 4 plus
Right.
x squared to the minus 1/2 power, which
Right.
could go on the bottom. Like it could be, and we talked this like 1 over 2 square root 4 plus x squared like that. But then you have to multiply by the derivative of the inside function. So that's the 2x part.
Right.
Okay, and I heard some different stuff than that. I mean, maybe you were trying to simplify it a bit, but these twos cancel. Uh, this is not uncommon. It's not uncommon for students who the chain rule thing just never gets made clear because you don't do enough classes in the beginning of the course. But this is the derivative part of the inside function. That's what gets paired up over here. Over square root 4 plus x squared. So this is the derivative, 1 over the inside function here, times the derivative of the inside function, which is here. Okay. I'll just go right to 65. We'll spend the last 10 minutes on the implicit derivative stuff. So this absolute value doesn't matter. You can just ignore it. I don't know why they're even putting this in. I mean, I know why, but I don't think it's helpful for you as a student. Like it looks like, oh my gosh, it's totally different. It's like, yeah, it actually doesn't matter. So this one though, you do want to rewrite. You want to do the natural log cosine x minus the natural log cosine x minus 1. Like that. So remember it's top minus bottom. Is that okay?
Yes.
All right. So the derivative here is 1 over the inside function times the derivative of the inside function. What's the derivative of the inside function here? It's derivative of cosine.
Negative sine. Right.
Negative sine x. Good. Minus 1 over cosine x minus 1 times the derivative of the inside function.
So that would be negative sine still.
Now this is a good one because it simplifies, meaning like sine over cosine. Do you remember that from your trig course?
Yeah.
Sine over cosine is tangent. On the right here, this negative goes with this negative, so it becomes plus sine x over cosine x minus 1 like that. Is that okay?
Yep.
All right. So we've done implicit derivatives, but we've not done them, I guess, with ln. Maybe why they're coming back up in the part of the course. I have no idea why. That's what they are. The derivative of x is always the same. You just take the derivative with x like you always do. So the derivative of x squared is 2x. Got it done. Now, minus, bring the minus down, okay? 3 times natural log of y, so it's 3 times 1 over y. The derivative of the inside function y is 1, but whenever you have a derivative, implicit derivative with respect to y, you always put a dy dx in. That was the key difference between x and y. Whenever you take a derivative with respect to y, you have to write a dy dx at the
Right.
end. Plus, that's this plus, the derivative of y squared, so you treat y squared like x squared, so that's 2y,
You are
and then dy dx, the derivative of 10 is 0. Do you remember what to do from here?
Well, first we should simplify.
Yeah, we simplify a little bit here. 2x minus 3 over y dy dx plus 2y dy dx equals 0. That's fine. But the main thing here is you're solving for dy dx.
Right, yeah.
So will you do that for us here?
Yeah. Um. So I got 2x over 3/4 all over 2, or 3 over y all over 2y. And then, or is equal to 2 dy dx.
Okay, so yeah, the couple of things I think would be helpful here. One is let's just move the 2x over.
Yeah,
Typically move that over. So then, and then I'm going to reorder these. So it's 2y dy dx minus 3 over y dy dx. The reason is that you really want the leading one positive. That's like a preference, we'll say.
right.
But that's up to you. And then so you factor out a dy dx, factor out. That's I think what was missing from what you said. So that becomes 2y minus 3 over y equals minus 2x. And then you divide both sides by the what you've got here. So 2y minus 3 over y. So you end up getting dy dx equals minus 2x over 2y minus 3 over y, like that. Okay. Okay, now, a couple of things you could do here to simplify. You bad to leave a fraction within a fraction, and this is all for the multiple choice stuff. So you'd multiply the top and the bottom by the thing that eliminates the fraction. So it'd be minus 2xy over 2y squared minus 3. Please take a look at that and see if that's clear, because that's a thing you will see on the test for sure. Like they would probably not leave it like this.
Yeah, that makes sense.
Okay, now the other thing is that they might play around with the signs, like they could take the negative away from here and put it on the bottom. So it would look like this 2xy, and then it'd be 3 minus 2y squared, because the 2y squared becomes negative, the minus 3 becomes positive when you move it down because you apply it to both. And then you typically put that in front, or it could be, minus 2y squared plus 3. These are some of the absolute toughest to figure out if all the answers are the same. Um, they're just really similar, I guess you should say. So we don't have a ton of time. We should do 82 though to kind of close out here. Um, So 82, natural log there right in the beginning. That's really where I thought they were going to go with these, but so the derivative is of natural log is 1 over the inside function. So 1 over xy, but then you got to multiply by the derivative of xy, which is we did this before. It's product rule. So it's x dy dx first times derivative of the second plus the second times the derivative of the first, like that. So that might be something to put on a note card or something for your reference sheet for your exam. X dy dx plus 1y plus that's this plus here. Derivative of 5x is 5 equals 0, like that. All right, so then probably good to multiply in by the 1 over xy to both of these. You'll see some cancellations. You get x dy dx all over xy plus 1y over xy plus 5 equals 0. You can see the x's cancel. See the y's cancel. And you end up getting dy dx over y plus 1 over x plus 5 equals 0. Might seem odd, but probably good to clear out that y right now, multiplying everything by y, both sides. So you end up getting dy dx plus y over x plus 5y equals 0. And you can see it's pretty straightforward to solve for dy dx. You just move this stuff to the other side. So dy dx equals minus y over x minus 5y.
Okay.
All right, we're going to stop there for today.